Good evening. Welcome to the ICSE Class 10 Physics tutorial. Today's topic is refraction at plane surfaces. I have taken some questions from this chapter. Today we are going to discuss them. Like the first question is, define refraction of light. Define refraction of light. This is the question. Now answer. When a ray of light passes obliquely from one transparent medium to another transparent medium, it changes its direction. This phenomenon is known as refraction of light. Listen once again. When a ray of light passes obliquely from one transparent medium to another transparent medium, it changes its direction. This phenomenon is known as refraction of light. So when you are asked this question in the examination, for example, the question is define refraction of light, you will write down this much. Now see the explanation. See, in the answer we are saying when the ray of light passes obliquely. This is important, because if it falls normally, because it passes normally, then no deviation takes place. Then it does not change its direction of propagation. And we are talking about refraction of light, and we are saying that when the direction of propagation of the ray of light changes. So when will it change? When it doesn't pass perpendicularly. So that's why we are using the word obliquely. When a ray of light passes obliquely from one transparent medium to another transparent medium, it changes its direction of propagation. This phenomenon is known as refraction of light. This incident, this happening, is known as refraction of light. Okay? Now, and if you want to see, so see, look, have a look. Suppose this is a glass block. This is a glass block, denser medium. At this point, we are drawing a normal, and we take one incident ray like this. Alright. Now what happens when this ray of light enters from air to glass, from rarer medium to denser medium? What happens? It does not go straight. If there had not been this glass block, the ray would have traveled like this straight. But in this case, this doesn't happen. When the ray of light enters from this air, rarer medium, to glass, denser medium, it changes its direction of propagation. Now, I'm not saying, right now I'm not saying it bends towards the normal, or when does it bend towards the normal, or when does it go away from the normal. I'm right now only saying that it changes its direction. Whether it is bending towards the normal or it is going away from the normal, it is changing. The main purpose is if it is changing the direction of propagation or not. Yeah, it is changing. Whether it is bending towards the normal or it is going away from the normal. Alright. So in either case, we say that refraction is taking place. So in this case, what happens? And now, one more thing I would like to tell you. When the ray of light enters from rarer to denser medium, it bends towards the normal. And when it enters from denser to rarer medium, that I'll show you, it goes away from the normal. That also you see. So what happens? This is rarer medium air. And this is glass. This is glass. Alright. Now, the ray of light bends towards the normal. It bends towards the normal. This is a normal. The actual path is this. If there had not been this glass slab, this glass block, the ray would have traveled like this straight. But because of this change of medium, rarer, denser, or denser, rarer, whatever, change of medium, then it bends towards the normal. Now, and reaches till here. Now from here it has to come out of the glass block. It has to emerge out of the glass block. Now in this case what's happening? Now the ray of light is traveling from denser to rarer medium. Now you forget about this. Okay. Now your incident ray is this. And it is traveling, it is entering from denser medium to rarer medium. So when the ray of light enters from denser to rarer medium, it goes away from the normal. It goes away from the normal. So this is a normal. This is a normal and it goes. Actually it should have gone like this, but no, it is not going like this. It goes away from the normal. Alright? It goes away from the normal. Actually the actual path of this ray, the ray in the denser medium, in the glass, the path is this. The path is this, straight. But no, it is going away from the normal. Alright. So whether the ray of light is entering from rarer to denser medium or from denser to rarer medium, in either case, it changes its direction of propagation. Alright. And this phenomenon, this incident, this deviation from its original path is called diffraction of light. Alright? And this will happen only the ray passes obliquely. So that's why the word obliquely is important when you are writing down the definition of refraction of light. Use logic. Not necessary that everything is there in the textbook. Or maybe you are referring only one textbook, you see other textbook also. Alright. So this is question number 1. Now question number 2. The second question arises, what is the cause of refraction of light? So very simple one-line answer. The cause of refraction of light is the speed is different. The speed of light is different in different mediums. In medium 1, the speed of light is different. In medium 2, the speed of light is different. Because of the difference in the speed of light, because the speed of light is different in different media, the refraction takes place. Alright? Now, actually we define refractive index like this. See. Actually we define refractive index mu is equal to C upon V. Mu is equal to C upon V. Refractive index of a medium is defined as the ratio of the speed of light in air or vacuum to the speed of light in that particular medium. Alright. So that means mu we are defining in terms of the speed of the two media. Suppose we are in medium 1 and medium 2, and in medium 1 the speed of light is V1, in medium 2 the speed of light is V2, then we write down V1 upon V2. Mu is equal to, then in that case we can write down V1 upon V2. What do we say? V1 upon V2. V1 upon V2. Got it? So that means the refractive index is defined in terms of the speed of light in the two media that we are talking about, or in different media. That is why, and since the speed of light is different in different media, and we are defining in terms of speed of light, so that is why the refraction takes place. Alright. Next question. Illustrate the following terms with the help of diagrams. And which are those terms? The terms are like incident ray, the normal at the point of incidence, the refracted ray, the denser medium, rarer medium, etc., which you can see on the screen. Right. So the question is there. The question is illustrate the following terms with the help of diagrams. Right. And you see on the screen the answer is also given. There is a diagram, and everything I have written very, very clearly. What is incident ray, what is normal, what is angle of incidence, what is the refracted ray, what is the emergent ray, etc. Everything I have written very clearly. You please see on the screen. Alright. Now, next question is state the laws of refraction. 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 Answer. There are two laws. The first one is the incident ray, the normal at the point of incidence, and the refracted ray. Now you know all these things. Okay? Just now you have seen. Just now we discussed incident ray, refracted ray, normal at the point of incidence, and now I am going to use them. So what are the laws of refraction? There are two laws. First, the incident ray, the normal at the point of incidence, and the refracted ray, they all lie in the same plane. They all lie in the same plane. If you see the previous diagram, which I just showed you. Alright. Second is, this is the first law of refraction. Or the second law is the ratio of the sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. Right? And we write mu is equal to sin I upon sin R. The ratio, what I am saying, what did I say? I am saying the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media. Alright, that means I am saying this. I am saying sin I upon sin R is a constant, and that constant we are calling mu. This is the second law, the ratio. Now if you remember this, you can write down the second law. If you remember this, sin I upon sin R is a constant, and that constant we are calling mu. The ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media, and this constant we call the refractive index. Here I am writing 1 and here I am writing 2. And this constant we say that refractive index of second medium with respect to the first medium. Okay? Alright, so they are the two laws of refraction. Now another important thing, listen. Please listen carefully, because in maybe in your book you will see something different. This second law, that means sin I upon sin R is equal to mu. This second law is called Snell's law. in one book I saw, it is written both the laws are Snell's laws. No, only the second law is called Snell's law. Alright? Both the laws are laws of refraction, and the second law is also called as Snell's law. Sin I upon sin R is equal to constant 1 mu 2. Alright? Fine. Now, next question. Define refractive index of a medium. So we just define mu is equal to C upon V. Alright? Mu is equal to C upon V. Mu is equal to C upon V. Refractive index of a medium is defined as the ratio of the speed of light in air or vacuum to the speed of light in that particular medium, of which we want to find out the refractive index. Alright. So mu is equal to C upon V. Now, what is absolute refractive index? If we find out the refractive index with respect to air or vacuum, then that refractive index is called absolute refractive index. See, understand, sometimes the question is asked, what is absolute refractive index? So the refractive index of a medium with respect to air or vacuum is called absolute refractive index of that medium. Alright, clear? And one more thing I would like to tell you, because it's a ratio, so it doesn't have any unit. Alright, next. State the conditions when no refraction takes place. Next question. State the conditions when no refraction occurs. When no refraction takes place. What are the conditions? The first condition is there only in the definition of refraction of light. Alright? The first condition is I should be 0. I should be 0. I should be 0. That means the ray of light should pass normally, should fall normally on the surface. I should be 0. Angle of incidence should be 0. I is angle of incidence. We discussed. I showed you in the figure also. I showed you on the screen. Right? So I should be equal to 0. If I is 0, no refraction will take place. What is the question? State the conditions when no refraction occurs. So when I equal to 0, that is when the ray of light is not falling obliquely, when the ray of light is falling normally, then no refraction will take place. Refraction will take place only the ray of light is falling obliquely. That's why we defined, when we were defining diffraction of light, we said when a ray of light passing obliquely from one transparent medium to another transparent medium, it changes its direction of propagation, and this phenomenon is known as refraction of light. Got it? So the first condition is I is equal to 0. That means the ray of light should not fall obliquely. It should fall normally. And second is the refractive index of medium 1 should be equal to the refractive index of medium 2. Means the refractive indices of both the media are same. Alright, so mu 1 is equal to mu 2. Mu 1 is equal to mu 2. If you can say, if you are calling that mu 2, then mu 1 is equal to mu 2. Alright. So these are the two conditions. That is your answer. And the question was, state the conditions when no refraction takes place. You have write down when angle of incidence I equal to 0 first, and second when the refractive index of medium 1 is equal to the refractive index of medium 2. Next question. Draw a diagram showing the formation of multiple images in a thick plane mirror. Draw a diagram showing the formation of multiple images in a thick plane mirror. Also explain why the second image is the brightest. The second image is the brightest. Alright. So for this we will, I'll show you the diagram. Please see the diagram. Please see the diagram. The formation of multiple images in a thick plane mirror. In the diagram, you see there is a thick plane mirror MLPN. Alright. NP is the, or PN is the reflecting surface, polished surface. From here the reflection will take place. Alright. And Mn is the thickness of the mirror. That means that part is Mn is glass, denser medium. Alright. So inside, in this area, Mn, MLPN, in this area, the rectangular area, the glass, which is a denser medium, refraction will take place. And when the ray of light reaches on the surface Pn, when it hits the surface Pn, which is the polished surface, there the reflection will take place. Okay. Now see, there is an object A, pin or any illuminated object A. From A, we are taking two rays. One ray is falling normally on the surface LM. Alright? No refraction is taking place because it is falling normally, I0. It goes straight, it hits the polished surface PN and then goes back, following the principle of reversibility of light, which I didn't discuss. Alright. Now the second ray, AB, you see how AB is coming. AB is falling at the point B, which is on the surface of separation of the two media, the air, rare medium, and the glass, denser medium. So at B, see there is a normal also. I have drawn a normal also. At B, refraction will take place. At the same time, partial reflection will also take place. You know, suppose, for your understanding point of view, suppose 5% of light, a small quantity of light, a small amount of light, 5% of light at B, because at B refraction has to take place. Of course refraction will take place because it's a transparent denser medium, glass. But at the same time partial reflection will also take place. Suppose 5% of light is reflected along BP. Alright, 5%. So 95% is entering, suffering refraction and bending towards the normal because it is entering from rarer to denser medium. Hope things are clear. Alright, I am waiting for a few seconds. Please have a look. See that? Is that fine? AB. See BB dash. BB dash is the refracted ray with 95% amount of light, and 5% has suffered reflection along BP. Alright. Now when BP is produced in the backward direction, it appears to come from A1, where the image is formed. The first image, A1, is formed, and this image is formed due to the reflected ray BP, whose intensity is only 5%. Intensity is less. Now 95% is refracted along BB dash. At B dash, it will suffer a strong reflection. Then also suppose 5% is absorbed. So out of 95%, suppose 5% is absorbed. So then also 90% of light is reflected back. Alright, and it travels along B dash C. So B dash C is the reflected BB dash and B dash C. So BB dash is incident ray. Now and B dash C is the reflected ray. Reflection is taking place because PN, CPN, where is PN? CPN. PN is the polished surface. Reflection will take place. Now B dash C, the intensity of light is 90%. At C again transparent medium. This side glass, that side air. Refraction will take place and partial reflection also. So partial reflection again, suppose 5%. Along CC dash, 5% light is reflected back. Partial reflection along CC dash. Alright. Then 85% of light is suffering refraction along CQ. Along CQ. 5% along CC dash. Remember this, 5% along CC dash, because now from here onwards we are going to deal with only 5% of light. 5%, the intensity of light is only 5%. And this will gradually decrease as we move ahead, as we go on. Alright, as we move on. And 85% light suffers refraction along CQ. Maximum intensity of light along CQ. And when this CQ is produced in the backward direction, it appears to come from A2, where the image is formed. So that means A2 is the image formed due to the ray of light CQ with maximum intensity of light, 85%. So naturally it has to be the brightest one. So you are getting your answer also. Alright, which we are going to say in the end. Alright. So A1 was due to 5% of light. A2 is due to 85% of light intensity. Now what about CC dash? CC dash is only 5% of light. So 5% of light is reflected back at C dash. Suppose the entire 5% is reflected back, then also it is 5% only, no? And as we move ahead, as we go ahead, as we move on, it has to decrease only from 5%. So 5%, 4%, 3% like that. That means it is the ray CQ which has the maximum intensity of light, and that is why, and this ray is forming the image A2, and that is why image A2 is the brightest image out of so many images formed in the case of a thick plane mirror. The intensity of rest of the images decreases. Alright? Clear? Got the answer? Now look at the figure. Look at the figure. Again and again you look at the figure. Is the figure clear? Once again you see how we are taking two rays. Alright? Fine? Hope it is clear. I tried to explain to you each and everything in a very simple manner. Alright. So once again you say this. Listen to my explanation. See the figure. Hope things will be clear to you. And it's some of the students, they find it difficult how, sir, and there are so many rays, and why the second image is the brightest one. So simple, because the intensity of light is maximum 85%. That is why the image A2 is the brightest one of all the images formed in the case of a thick plane mirror. Okay, now next question. Define the term angle of deviation delta. Define the term angle of deviation delta in the case of a prism. Right, angle of deviation delta produced by a prism. Define the term angle of deviation produced by a prism, and the symbol is delta. We use delta to represent angle of deviation produced by a prism. So there is a prism. Look at it. This is a prism. Alright. We are taking one incident ray. We take one incident ray, We are drawing normal also. Normal. This is incident ray, so this ray is important like this. Incident ray. Alright. This is angle of incidence. This is angle of incidence. Suppose this is I. Angle of incidence I. Alright. Now the ray is entering from rarer to denser medium, so it bends towards the normal, towards the base. Alright. The actual path of the ray would have been this if there had not been this prism, glass prism. So the ray would have traveled like this. See, look at it. Look at it. So simple. So simple. The ray would have traveled like that if there had not been this prism. It is because of the prism that, because of the change of medium, that the ray of light is deviating from its original path. That means the refraction of light is taking place and it is bending towards the normal because it enters from rarer to denser medium. So it bends towards the normal. It bends towards the normal. Okay. Now what will happen again at this point? Again there is a change of medium. So what will happen? How will it go? Let's draw normal. Let us draw a normal. Let us draw a normal. Alright? Let us draw a normal. Now see this normal. Now the ray of light is entering from denser to rarer medium, so it has to go away from the normal. The actual path of the ray is this ray. I'm talking about this ray. This ray. No, this story is over now. This story is over now. Now talk about this. The ray of light is entering. You hide this. Hide this. This story is over. The second chapter is started. The ray of light is entering from denser to rarer medium. The path of the direction of propagation is this. From here, if you say this, it should go straight, but it is not going straight because it will suffer refraction because of the change of medium. So how will it go? Because it enters from denser to rarer medium, so it will go away from the normal. Away from the normal. Where is the normal? Is this. Alright, so away means this side. Away from the normal. Away from the normal. So it will go away from the normal. Alright? It goes away from the normal. Alright. Just try to understand. It goes away from the normal. Now see, how much is the deviation produced by this prism? The actual path of the ray is this. But now the ray is going like this. If you produce in the backward direction, see this. If you produce this emergent ray, I have shown, right? If no, then once again you listen to me. This is incident ray, this is refracted ray, and this is emergent ray, emerging, coming out of the prism. So the emergent ray produced in the backward direction and the incident ray produced in the forward direction. Alright. How much is the deviation? This deviation has been produced by this prism, and this deviation is called angle of deviation delta. So can you tell me what is the deviation? What is the deviation? Children, say this. This is the actual path of the ray, and now the ray is going like this. So this much is the deviation. This much is the deviation. Say this. This much is the deviation. This much is the deviation. This is the deviation. The ray which should have traveled like this, the ray which should have gone like this, is now going like this. So this much is the deviation, and this is called angle of deviation delta. This angle. This angle. Which angle? This angle. This angle. Or this angle. This angle. Same thing. Okay, clear? This angle are the same thing, no? This angle, this same thing. This angle. This is called delta. This is called delta, angle of deviation delta, produced by the prism. Alright, now can you define what is angle of deviation delta? Can you define what is angle of deviation delta? What was the question? The question was, define the term angle of deviation delta. Yes. Sorry. The angle of deviation delta is the angle between the incident ray produced in the forward. See, you don't have to learn it. Understand. Imagine, yeah, there is a prism. There is a one incident ray should have traveled like this, but no, it's not doing that, it is going like this. Imagine. It should have traveled like this, but no, it is not traveling like that, it is going like this. So how much is the deviation? This much is the deviation. So what is it? It is nothing but the angle between the incident ray produced in the forward direction and the emergent ray produced in the backward direction. Emergent ray when you produce in the backward direction and incident ray when you produce in the forward direction, then they are meeting at this point. Alright, and at this point this angle is formed, and that is called angle of deviation delta. Hope it is very, very clear. Okay? Certain definitions, if you understand, you need not learn them. You can write down in your own word. And here see, some of this, sometimes the students are confused with a word which generally the teachers tell the children, keywords. Keywords are very important. Please, when you are writing down the definition, there should be keywords. And now you are confused with the keyword. Oh my God, that is another headache. Now you are finding out what are the keywords in this definition. Alright. So here there's you don't have to learn the definition by heart as it is given in the textbook. No, there's no keywords only. Actually, keywords means what? Something, a word or a clause which is required to give the complete sense. If you don't write down that word, if you don't write down that clause, then the meaning, the sense is not complete. Alright, so if you are confused with the word keywords, forget it. No keywords. Important point, important word. The word which is very, very important, without which the definition is incomplete. The principle is incomplete. The law doesn't give you a complete sense. So those words, those important words, we call keywords. I don't tell the children keywords most of the time. And if I tell the children these are the keywords, then I explain to them, it should not be another problem. We are trying to find out a solution and we are creating any problem by introducing this word keywords. Alright. So please understand. That much sense we have if we are saying something, so does it give complete sense or not? Which word is required so that it gives you a complete sense, a meaningful sentence, a complete sentence? That word is the keyword. So why do you take a headache? Alright, for example, if you are writing Ohm's law, the current flowing through a conductor, according to Ohm's law, there are keywords. According to Ohm's law, the current flowing through a conductor is directly proportional to the potential difference applied across the ends of the conductor, provided that the physical conditions and the temperature of the conductor remain the same. Alright. Now see, if you don't say the temperature of the conductor remain the same, will you get V upon I is equal to constant all the time? No, you won't. That means this is important. The temperature should remain constant. This clause, this term is important, because if you don't keep the temperature constant, provided that the physical conditions also, and the temperature of the conductor remain the constant. If the temperature does not remain constant, then you will not get V upon I is equal to constant. That means the Ohm's law doesn't hold good. Alright, so that means that temperature is keyword. Important for the for a complete definition. Ohm's law, complete Ohm's law. The Ohm's law is complete only. Ohm's law is complete. It gives you complete sense. It is true when you say that. Apart from so many things, when you have to say that yes, the temperature also should remain constant. All right. So I think now keyword will not be a headache for you. All right. So this is okay. Define the term angle of deviation delta. Right. Now next question is state the relation. This is A, angle of prism A. This is A, B, C. So this angle is called angle of prism A. This is I. All right. Now, the next question is state the relation between IA and delta m. Now a new term is coming, delta m. But before delta m, let me tell you one important relation. I plus E is equal to A plus delta. I plus E, I plus E is equal to A plus delta. Alright. I plus E is equal to A plus delta. This is an important relation where I is the angle of incidence and E is the angle of emergence. Angle of incidence is the angle between the incident and normal, and angle of emergence E is the angle between the emergent and the normal. That means this angle. Definition, learn definition. No definition, understand definition. Understand this angle, this angle. This is E. Okay, this is E. This is E. The angle between the incident and normal is called angle of incidence, and the angle between the emergent and normal is called angle of emergence. So I plus E, in some books they write I1 and I2 also. Alright. Fine. So both are okay. I think this is better. So I plus E is equal to A plus delta. The abbreviations used, the symbols used, I, E, I just told you, A, the angle of prism, and delta, just now we discussed, just now I explained to you. The angle delta is the angle of deviation produced by the prism. So this is the relation. Alright. Now what is angle of minimum deviation, delta? What is delta? Angle of minimum deviation, delta. Alright? Delta, angle of minimum deviation. We write like this. Delta, angle of minimum deviation, delta. When, now listen, again you listen, understand. You don't have to learn. So many things you can write down on your own if you understand physics. Physics is something which you need to understand. Alright. So, I and E, if I and E they are equal, if I is equal to E, then in that case the deviation produced by the prism is minimum, and in that case this refracted ray, this ray inside the prism, that becomes parallel to the base. Alright, that also please remember. So when I and E they are equal, delta becomes delta m. Alright, so another important result, a very simple important result I am going to tell you, which if you forget, you will not forget only because you know how we are deriving it. How are we reaching the result? You are not mugging it up. You are not learning it by rote. You understand how are you getting it. Alright, so I plus E is equal to A plus delta. When I is equal to E, then delta becomes delta m. So what shall we get? I plus I. Suppose in place of E we are writing I. So is equal to A plus delta m. Delta m. Alright. So I plus I is 2i. So 2i is equal to a plus delta m. Another important relation. Very good relation. Beautiful relation. So 2i is equal to a plus delta m. Alright. So you can write down then 2i is equal to a plus delta m. What do you say? If you forget, you will not forget only because you know how are you reaching this result. 2i, that means I plus I, one I is I, the other I is E. Why I and E both are equal? Because it is the case of minimum deviation, and in this case the refracted ray is parallel to the base of the prism. Is that fine? Now next question is, what are the factors affecting delta? What is delta? The angle of deviation, delta, produced by the prism. So what are the factors which will affect delta? Again, I am telling you a trick. Very easily you can remember. There are 4 factors, but how will you remember? Just have a look. Look at it. You remember only one line, I a mu lambda. I a mu lambda. I will remember I a mu I a, then mu and lambda. I a mu lambda. Alright. Okay, fine. I a mu lambda. These are the 4 factors. I a mu lambda, I a mu lambda, I a mu lambda, I a mu lambda. What are the factors which affect the angle of deviation delta? Answer is I a mu lambda. But this you will not write on the examination. Now you have to write down in detail. I a mu lambda I. Oh, that means the angle of incidence I. Alright. The angle of incidence I. A, okay, you know that is the angle of prism. Second factor will be the angle of prism, capital A. Third, the refractive index mu of the material of the prism. If you know mu, you will write down. Definitely you will be able to write down the meaning of mu. Mu is what? Refractive index of what? We are talking about prisms, of course prism, but it is not of prism, it is of the material of the prism. So refractive index of not prism, refractive index of the material of the prism. Alright. So angle of incidence I, angle of prism A, refractive index mu of what? Of the material of the. Of is important, very, very important. Of. Complete answer you have to give. You have to write down the complete statement. Alright. Wherever you are writing, for example, somewhere one of the factors is temperature. So you cannot write down only temperature. You should write down temperature of the conductor. Of these important. So here refractive index mu of the prism. No, of the material of the prism. And fourth, color or wavelength of light. Lambda is wavelength. Color or wavelength of, and there are two again, color and lambda, color and wavelength, they are not two different factors. If you are using them as 2 different points, you will be given, they will be taken as only 1 point. So that also you have to be very, very careful. Color is 1 point you are writing, and wavelength another point. No, they are same, color or wavelength of light. So they will be taken as 1 point. So in the examination, please don't make such mistakes. Alright, suppose you forget I, then you are writing angle of prism A and the refractive index of the material of the prism mu, and then you are writing color of the light used, and then fourth you are writing wavelength of the light used. No, they are not 2 separate points, they are 1 point. Alright. So be clear about that. So I a mu lambda, how will you remember I a mu lambda? Factors affecting delta are I a mu lambda. Alright. Now let's see some simple applications of refraction of light. Some simple applications. Very simple. Okay, then the first, the next question will be, illustrate real and apparent real and apparent depth by drawing diagram. Next question is, illustrate real and apparent depth by drawing diagram. So we are taking one question. Suppose there are 2-3 very familiar questions. So one we are taking. Suppose we are taking an object O or any print O, and on that O, you can call it a mark, you can call it a print, you can say that O is a point. Alright, and on that point O, we are going to talk about real and apparent depth. The question is, illustrate real and apparent depth by drawing diagram. In the diagram, we have to show that this is the real depth and this is the apparent depth. So we are taking one point O, a print O, any mark O. On this mark, we are placing a glass block. On this mark O, we are placing a glass block. Alright, and now we see obliquely from the above, from the air, from the above, from the air, the side, obliquely we see. What do we see? That we are going to discuss. And we will see that this O appears to be raised up. So this depth is the real depth, and when it appears to be raised up, suppose the image of O is found somewhere here. Suppose, I'm going to show you. Suppose the image of O is formed somewhere here. I mean, when you see obliquely from the above, from the air, from somewhere here, suppose. Alright, from here if you see, alright, if you see from here, if it's from here, and then you see that the object is not here, the object is here, virtual image. Alright, so it appears to be raised up. That means the real depth is this. The real depth is this. And the apparent depth is this. This is the apparent depth. Alright, this is what the question says. Illustrate real and apparent depth by drawing diagram. Alright, I'm going to show you one diagram, very nice diagram. But first you understand, this is a glass block, the same example I have taken. I'll show you on the screen. We have taken a mark O. On that mark we are placing a glass block, and then the different rays we are taking, and then we see obliquely from the above, from the air, from the above, obliquely. Now, then what happens? Please see. Now see on the screen, as I told you, I'm going to show you the diagram on the screen. On the screen, as I told you, there is a glass block PQRS, and there is a mark O or print O or point O. On that print, on that mark O, we have placed a glass block PQRS. Now from O, one ray we have taken, I have taken, which is going normally. So it goes straight without any deviation. You can take this as a ray also, and you can call this as only normal. It's okay because already we are taking two more rays. Anyway, now one ray we are taking OB. This ray has to travel from denser medium to rarer medium. So OB at the point B is at at the surface of separation of two mediums, denser medium and rarer medium. So at the point B, now the ray has to enter in the rarer medium, right? So OB, the incident ray, when it enters the rarer medium, it will suffer refraction and it goes away from the normal because it is traveling from denser medium to rarer medium. Now when we produce, and there is a normal also at the point B, there is a normal also with 90-degree angle, very clearly I have shown it. Right. Now when we produce this BC, the refracted ray, in the backward direction, it appears to come from point I. Now we take one more ray, OD. Now OD again suffers refraction because it also travels from glass block, which is a denser medium, to air, which is a rare medium, and so it has to go away from the normal. So it is going along the direction D. When D is produced in the backward direction, it also appears to come from I. So both the rays appear to come from a point I, which is the virtual image of the point O. Alright? So I is the virtual image. So can we say that therefore AI or IA, which I have written there, IA is the apparent depth and OA is the real depth. Is that fine? Do you understand? Alright? So but we are, once again I am telling you, we have placed a glass block on a Marco, on a Printo, on a point O, and we see this point, this mark, this print from the above, from the air, obliquely. Then this is what happens. Alright, the image of O is formed at I, the virtual image. So I is the apparent depth and OA is the real depth. Hope it is clear. Is it? Alright. Fine. So this is your, as you saw in the diagram, this is your, this total is real depth and this is apparent depth. Here a virtual image of O is formed. This is virtual image I at this point. So the point O is raised up. It appears to be raised up when you see obliquely from above, from air. Take a point O, take a mark O, take a print O. On that point, on that mark, you place the glass block, and as I showed you in the diagram, when you see obliquely from the above, from the air, you see that a virtual image of the point, of the mark, of the print O is formed at I. Alright, so the point O appears to be raised up. Alright. This is your apparent depth and this is your real depth. Along this, in the same way, in the similar fashion, you can explain a coin placed at the bottom of a vessel appears to be raised up. Right. Okay. The next question is, draw a diagram to show the bending of stick in water. Draw a diagram to show the bending of stick in water. Alright, so there is a nice diagram I have drawn. I am not going to draw here. I have already drawn. I will show you on the screen. You please see on the screen. Look at the screen. Alright. Now see, there is a stick. There is water. There is air, as you can see, and there is a stick OA. From the tip of the stick O, O is the tip of the stick and O is the stick. So from O, one ray we have taken, as we saw in the previous case, one ray is we are taking normally, which is going normally, means I0, so it goes without any deviation. So you can call this as normal only normal, ON is the normal, or you can call it a ray which is falling normally on the water air surface, and so it goes without any deviation. It's okay. Now we are taking two rays coming from O, the tip O. One ray is traveling in the denser medium water along OC. At the point of C, there is a normal also at C. At C, the ray has to enter from water to air, that means from denser to rarer medium, so it will go away from the normal, and it is going away from the normal along CX. Now when CX is produced in the backward direction, it appears to come from I. One more ray we are taking, OD, which again enters from denser medium, that is water, to rarer medium, that is air, and suffers refraction and goes, because it is traveling from denser to rarer medium, so it goes away from the normal. Now it travels along dy. Now when dy is produced in the backward direction, it also appears to come from I. So both the rays, they appear to come from a point I, which is the virtual image of the point O. And the same is true for every point of the stick inside water from O to B. I am repeating. The same is true for every point of the stick inside water from O to B. Alright. And now you see the image of OB inside water as IB. Alright. So that means the stick is bent at B, as you can see in the dotted lines. All right, got it. So the question was, draw a diagram to show the bending of stick in water. Draw a diagram to show the bending of stick in water. So we are showing the bending of stick in water. The stick is bent at B. The actual stick is OA, and now we see this stick as IBA. So the stick is bent. Alright, got it? Understood? Fine, clear? Understood? Thank you so much. Thanks.